above this. It would look just like this, right? So that's important that you see that in the directions. The vector field F is shown in the xy plane and looks the same in all other horizontal planes. In other words, F is independent of Z and its Z component is 0. Oh, thank you. Look at the Z component 0. Is the divergence of F positive, negative, or 0? So we're going to start with that. This is number 9, and we're going to look at the divergence of F. As for letter B, we'll get that in a second. But we're going to start with this. Is the divergence of the vector field positive, negative, 0? Explain. Okay, so we'll go to it. It's not hard to do. So I'm going to look at this thing right here, and we're going to find the divergence of F, right? But what is F? I don't know what makes up this vector field, although I bet you a lot of you can invent the vector field that does this. I'm being serious. I bet you everyone in this room could invent the vector field that gives a representation like this, where they're all the same, then they kind of shrink, and they get smaller and smaller, but we won't do that. Let's just think of F right now as a P, Q, and an R. Does that sound good? Let's call vector field P, Q, and R. So far, so good. Now, let me go back to this. What did they say about the Z component?
0.
It's 0. Because they said this looks the same in all other horizontal planes. So I'll write this again. What do we know about this vector field? We can call it P, Q, and what?
0.
0. Okay. And we got to find the divergence of F. So let's start with the definition. What's divergence of F? Divergence of F is
d dx
yeah. Del cross or del dot?
dot
Dot F.
f.
So let me write this out. It'd be like d dx, or dy, dz. I also want to say delta. Dot product with
p
the
q
P and the Q and some. It was R, but I'm going to put a 0. Right? I get 0. So what do you get out of this? I get the partial root of P with respect to a
dx
x plus the partial root of Q with respect to a what?
y.
Y. Do I have to put the last part?
No.
No, I'll write it with a plus 0, right? And I'm going to duplicate that, and I'll turn that off so we can highlight it. What's this looking like? It's doing, these are big, all the same, then they got smaller, then they got smaller. Make sure I line these up properly. That's good enough. That's pretty much what's going on with this vector field, right, everyone? You know what you see here? These are all identical, they're equivalent. These are, they keep shrinking in that case. So I can hit the lights, we can just focus on this. Not turn on the light, I see it. Let me make sure all line up. X and Y, so how can we read this from this vector field? It's not hard, everyone, this is the vector field. Does this mean rate of change?
Mm-hmm.
So, let's look at rate of change of x component, look, x component of vector in the direction of the positive x-axis. Let me say that again so you know how to read this graph over here. Rate of change of the x component of the vector field in the direction of the positive x-axis. So where's the positive x-axis? That way? Okay, let's look at these vectors. And what's the x component vector here? 0. Andrew, great. Does someone agree? See that vector right there? I mean, like the y is like a 5 or something. The y component, what's the x component? What's going on with the x component of these vectors as I go in the direction of the positive x-axis? Are they increasing or decreasing, or are they zeros?
0.
They're all zeros. So what's the rate of change of them?
0.
0. Outstanding. Now, let's be careful of that. Rate of change of the y component of the vectors as you move in the direction of the positive y-axis. Okay. So I can take this column. And what's going on with the y components of these vectors? Are they increasing or are they decreasing? They're shrinking. And that means they're what? This is negative. So what's this final answer? If you recall the question, they go, you got to determine whether the divergence of f is positive, negative, 0. What can we say?
Negative.
You got it? There we go. The divergence of f is negative. By the way, you might find it more fun. I always think they should have made this problem, you figure out the vector field, or figure out some vector field that would make it do this. I know you could do it. Do you agree all of these components this way are doing the same thing? So it's like the x values aren't affecting it, so both, whatever that's in here, this and this would just be in terms of y. Does that help? I bet you could figure it out. And then you could just do the divergence to see it's always going to be what? Negative. But that was easier. That was an easier way. Cool. Hey, let's now do this letter B thing. They say talk about a curl, but let's use a different vector field. Okay? Let's do a different curl. And you go, why? Well, I want to give you a heads up. Curl of a vector field deals with the rotation. Curl of a vector field deals with the rotation, if you recall me talking about that earlier. Do you see rotation in this thing?
No.
Guess, you can do all the math. Guess what happened if you did the curl of this?
0.
You can do all the math, you get a curl of B0, the curl of that vector field. You could do all that math. So I thought, let's pick another one. So I'm going to pick the one, nah, I don't like that. We'll do number 11. I'll pull it down. So let me just scroll this up. And we're now going to do the last thing we'll do. Number 11. And I can rewrite this on the board. So same question, number 11, we're not going to do divergence. We're going to find the curl of this vector field. The question is, can you find the curl of this vector field? Let me repeat the question that was in the book. This is what they said. They asked, determine whether the curl of the vector field is 0. They said, if it is not, in which direction does curl F point? Because curl of vector field is a vector. So let's go down to this vector field, and we're going to find the curl of this. And while you're giving it a shot, I'm going to repeat the drawing. So we can hit the lights and look at this. This will be the last problem. Right. These look about the same that way. And they're smaller. Okay? And then they kind of switch over, but they're small. And then they're a little bigger. Okay. That's probably good enough. Getting something like that, right? Just to give us an idea of that vector field. I do want to point out, these are all the same. They're equivalent vectors. All equivalent going that way. Smaller, smaller, really tiny, switching directions, we get it. So there it is. I'll hit the lights. There's the vector field. The question is, determine whether the curl of the vector field is 0. If not, indicate the direction in which it points. So last problem. So we're going to find it. Here's F. Keep in mind, what's this? 0. So I'm going to get the curl, which is equal to what? The cross product of del cross F. Okay. So let's do del cross F. What's del? ddx. dy. dz. P, Q, and what letter?
0.
I'll put 0 where it was because they said it was a 0. So I'll put a 0. IJ. Alright, let's see what we get. We got enough room to write all this stuff out. What's that first component? Partial of that respect to y.
0.
0. Minus the partial of that respect to z.
2.
So 0 minus
0.
d
Q.
q dz, because I'm saying q is representing something, right? I want to make sure, is everyone okay with that? Where q represents something in that component, there's a big capital Q. Alright, how about this middle component? That will be partial of that respect to x
0.
minus partial of that respect to z.
dp.
Right? And what's this last component? dq dx minus dp dy. Is that good? So it's funny, when I wrote the formulas on the board today, look what I wrote. I didn't write out all that crazy. You can if you want. This is what we're doing. So we find a cross bar. Okay. I'm gonna go back to the wording here and reread it, so you know what's going on here. Just so you didn't think I'm just saying something. They said in this problem, the vector field F is shown in the xy plane and looks the same in all other horizontal planes. So what should be the rate of change with the variable z, no matter what? If it looks the same in all other horizontal planes, it's not changing as you're going towards the positive z-axis. So what should this be?
0.
0. Does everyone follow that? So anything with respect to z should be 0. Because you're like, oh yeah, rate of change in the direction of the positive z-axis, all the vectors are going to look the same in the horizontal planes. So this is the 1.
0.
That's a 0. And this is a 1.
Same. 0.
So man, is this curl 0? Well, it all comes down to this last vector. What's going on here? And we're just going to take this slow. Are you ready? Let's start with that. dq dx. Partial derivative of which component?
Y.
Y component. So rate of change of the y component in the direction of the
X.
positive z-axis. Everyone here, I read that? So let's go on over here. Rate of change of the, what's going on with the y components as I go in the direction of the positive x-axis? What's going on with the y components? The y components are what? The y component there is 0. What's the y component of that vector?
Same.
0. They're zeros, so they're all zeros. What's going on with this? You're 0. Does everyone agree? That's what will throw people off. Go, what do you mean the y component is 0? They got to look at that vector. Oh yeah, that's like some, that has an x component, it has a value that isn't 0, but the y component is 0. And there's a minus, and what about this? P is which component?
X.
X component. So what's going on with the x components as you go in the direction of the positive y-axis? Aha! What's going on with these x components? I mean, think of this. This is like an x component of like -3. That's an x component of like a -1 for that vector. That's an x component of like a 1. That's an x component of like a 4. What's going on with the x components of the vectors as you move in the direction of the positive y-axis? To increase it. So this right here means this is positive. But you got to be careful. There's a what before the positive?
Negative.
It's a subtraction sign. So here's my answer to the question. They said determine if the curl of f is 0. If not, indicate the direction. Then I know that the direction of this vector field, right here, this is curl of f. You know where it points? It points in the direction of the, this is on the z component. Negative positive means the z component is negative, right? Negative z-axis. That's the answer. Does that make sense? Because this is coming out to be a negative value on the z component. So the curl of the vector field has to be pointing downward in the direction of the negative z-axis, whatever it is. Cool. And again, I always think, well, what's probably a more fun problem, if you try to figure out that vector field, or figure something out would do this. And it's not hard to do. Like pretend that's up at like y equal to, what's that, a y value maybe like 3, and at 3 it changed direction. You can figure it out like that, play around. Okay? So, man, everyone, great job with this. Great.